In this video, we will look at simplifying radical expressions. In this video, we will only be looking at radicands that are perfect powers, such as a perfect square or a perfect cube. Later, we will learn how to simplify radical expressions when the radicands are not perfect powers. For these examples, we will need our list of perfect squares, perfect cubes. We will refer to this one throughout the examples. And here's our first example. We need to simplify the square root of 225h squared k to the 8th. So the first thing we need to be aware of are the two properties that we've learned in this section. And these properties were explained in greater detail in the previous video. So if we look at our example, we have square root, which means it has an index of 2. Which is a positive even integer. So we're going to be looking at this rule right here. So what that means is we have to remember to put absolute value signs around our variable when necessary. Okay, so we have square root, and we have 225. Now, the nice thing about 225 is that it is a perfect square. It is 15 squared. So 225 is 15 squared. H squared is just h squared, so we don't really need to do anything to that. And k to the 8th is a perfect square as well. If you look in your list of variables, they have b to the 8th here. B to the 8th is a perfect square, because b to the 8th is b to the 4th squared. Remember your exponent rules. If you have a power raised to a power, you multiply the powers. So if I have b to the 4th power and I raise it to the second power, I have b to the 8th. So b to the 8th is a perfect square. So we can rewrite k to the 8th as k to the 4th squared. So what we want to focus on here is that we were able to rewrite everything underneath the radical sign as a perfect square. So what we have here is 15 squared instead of the 225, and then h squared is just h squared, and then k to the 8th, we are going to rewrite it as k to the 4th power squared. So we have 15h k to the 4th, and that is all being squared. So these exponents right here, our products to power rule tells us that we can put all the bases in a set of parentheses and raise them all to the second power. And then notice our index is also a 2. So we are going to use this rule here, but we are going to need absolute value signs. Now, I won't need the absolute value signs around the 15, because 15 is already positive. I will need them around the h. In the event that h is a negative number, you can't take the square root of a negative number, so it has to be the absolute value. Now, k to the 4th, even though we have an even index, we don't need absolute value signs around the k to the 4th because k is being raised to the 4th power. So even if k was negative, the fact that we're raising it to the 4th power would turn it positive. So this is our final answer. 15 times the absolute value of h times k to the 4th. All right, let's look at this next example. Again, we have to simplify the radical, but this time, as you can see, we have an odd index. So we are going to be using this bottom rule here, so we don't have to worry about the absolute value signs, because when you have an odd index, such as 5th root or cube root, it's okay for your answer to be a negative number. So again, I want to look for perfect 5th powers. And this is where our list is going to help us. So if we look at our list, the first one was 243. it was negative 243, but we can put the negative sign in. So that is 3 to the 5th power. So if 3 to the 5th power is 243, that means we are looking for negative 3, because negative 3 to the 5th power is what would give us negative 243. All right, if we go back and look, we have an a to the 15th, and we have a b to the 20th. And perfect. They are also perfect 5th powers. b to the 15th would be b to the 3rd to the 5th power, and b to the 20th would be b to the 4th raised to the 5th power. Because remember that rule, powers to powers, you multiply. So 3 times 5 and 4 times 5 would give us the 15 and the 20. All right, so let's rewrite our radical here. So instead of negative 243, I'm going to write it as negative 3 to the 5th power. And instead of a to the 15th, I'm going to write it as a cubed to the 5th power. And instead of b to the 20th, I'm going to write it as b to the 4th to the 5th power. So you can see our index of 5 matches all the 5th powers, which is good. Okay, so let's rewrite this. We have the 5th root of negative 3a cubed b to the 4th, all being raised to the 5th power. And again, since our index matches our power, and we follow this rule right here, our answer is negative 3a cubed b to the 4th with no need for parentheses. Excuse me, no need for absolute value signs, no absolute value bars, because we have an odd index.